let's take a look how to do mesh data sampling. Because we saw in the beginning that when you get the normals from some object like PLT surface or PLT volume and so on, you're actually getting the faceted look. So I'm going to create once again pretty much the same setup. I'll create a sphere. I'll create, let's say, PLT surface. I'll request 100,000 particles in the viewport, and I'll add a magma. And then on this magma, I'm going to tell it I want the color to be set to the normal. That's what we did in the very beginning. And we get this faceted look. But we want the actual smoothed normal. Currently, the way to do this is the following. I'll delete this normal, and I'll say I want to connect an nearest point operator. The nearest point operator is part of the mesh query tools. And I have two inputs that are mandatory. The one is called geometry. So I have to pick the geometry object that I need. I'll select the p-sphere, hit the get from scene selection. I can select 10 polygon objects, hit the button, and they will be added here. And if some of those is not a polygon object, will be skipped automatically. So I can pretty much select everything in the scene, hit the button, and all the geometry will be added. And then I need the lookup point in world space. So I click in this menu, and I get position converted to world space. All the channels in general are in object space within Magma. So if you're reading position, normal, and so on, they're in object space unless you convert them. And now the output in object space of the closest point to the surface, which is pretty much the same as the particle position itself, because the particle was created on the surface, is being output as color. That's not what we need. What we wanted is the normal, but this normal won't help. If I connect this normal, I'm actually still getting the faceted look, because the nearest point is also lazy and saying, no, I'm not going to deal with the smoothing information. I'm just going to get the normal from the face. But you see in the shortcuts here, we have a special button that says add face query. And the face query is a special operator that can sample any mesh channel that's available in the source geometry. And in this case, we have face normal channel and the normal channel. This normal channel is the actual smoothed one. And I'll add smoothed, and I'll add both the face normal and the smoothed one, and I'll disable the exposed position, which is there by default, but we don't really want it. Now, if I go and connect this guy instead of the normal, I get the smoothed look. But I have both here, and potentially I could actually make logical decisions and use the one or the other. I'm going to introduce a switch, which is the equivalent of an if in a programming language, and say, if the control value here is true, I want to use the smoothed normal. If it's false, I want to use the faceted one. And now we just have to set the rule. Right now it's set to false, 0, so it's using the faceted. If I switch this 1 to 1, I get the smoothed, but I can go a step further and say, okay, I have this position. I'm going to convert with a breakout and say, once again, we'll take the, here we are, we're going to take the x, which is the x-axis here, and we'll compare it with the logical operator, out L, less is also L, against 0. That means if it's less than 0, it will be true, and if it's greater than 0, it will be false. And now we get less than 0 smoothed, above 0 not smoothed. If I want it to be the opposite way, instead of changing this to greater, I'll go to the switch, press Ctrl W, and it will swap the two inputs. So now I have on the positive side the smoothed, on the other one not. And if I change this value to some other value, we can shift where the smoothing starts. And as you can see, particles are slowly getting more faceted, less smoothed. If I go down there, it's going in the opposite direction. So basically, you have a lot of control to sample, for example, mapping coordinates. If you have multiple named UV channels in your mesh, you can select any one of those and read multiple mapping coordinates channels and do math with them and output it and so on. So this is the more powerful way to get data, including normals. And it's actually working on barycentric coordinates. So if you disconnect this and add default barycentric coordinate, this is the center of a face, but you can go and say 1, 0, 0, and it will go to the first vertex and so on. So you can actually specify the exact position within the face where you want it. You see now the triangles because it's actually using the center of each triangle, and each particle gets a different one depending on which triangle is sitting on top.